Hi folks, I've been working on an update to my radio system using Wwise and Unreal Engine 5, and I just wanted to share my progress. So my first original system had a pool of AK components as transmitters, and all the receivers in range of the player let the transmitters know their transform. And then a SetMultiplePositions call did just that, set multiple positions for that station. This all works great, until you start to take spatial audio into account. In my little demo scene here, we have a single transmitter playing a drum loop. The white debug sphere is the AK component, which can live anywhere in the world in theory, but it will start here at world origin. We have 3 positions set, 1 at world origin and 2 others inside these beautiful rooms. Each room has a spatial audio volume with its own flavor of late reverb and a portal on its port side. And I'm starting off without any transmission or diffraction on the attenuations for the loop. I expected to hear each room's reverb as I got close to the set position and... oh no. It's still the outdoor verb. What happens if I move the AK component? Oh no. It's sending to that room's aux bus. Now let me turn on transmission diffraction settings for the loop, then maybe move the AK component. Oh no. The sound has 100% transmission loss, because the calculation is occurring at the AK component, not specifically from each multiple position. So set multiple positions works really well when the array of positions and the AK component source are in the same perceived space or volume. But this really doesn't give you a lot of options when using spatial audio. And doing workarounds, moving or repositioning the AK component could get messy and cumbersome. So I started to look for a new solution. Seth Whedon's presentation from Game SoundCon 2022 about the audio systems in Fortnite showed off the use of source buses, an Unreal audio component that basically spatializes audio bus outputs. This was a big inspiration for my original radio system, but at the time, I lacked the C++ knowledge needed to replicate that source bus idea using Wwise. There's an absolutely ancient post on the Wwise blog from 2017 talking about the new flashy 3D-Bus architecture, which laid the groundwork for all their spatial audio infrastructure. Their prime example in this post is using it to create a surveillance system. The key to this is the setGameObject AuxSendValues API. This creates a new listener-emitter association and routes an aux bus to a game object. Then all you have to do is set a listener to that game object. That sounded a lot like a radio system to me, so I gave it a shot. Using a game instance subsystem, I created AK game objects for each radio station play event and set their listener association to none at the start. With the aux sends primed, the sounds just sit as virtual voices broadcasting into the void, until a listener comes along and boom, music. It just takes one add listener call, disguised here as set station, which passes in the transmitter and receiver AK game object IDs as the emitter and listener input objects, respectively. Using a game instance subsystem here guarantees the game objects will continue to play even during level transition. Each emitter has an associated AK component, so it sets its own position, plays nice with spatial audio volumes and portals, and can receive RTPCs to modulate effects and output parameters.
It's amazing.
You can't use certain voice parameters on the 3D-Bus, including pitch. So I'm using a pitch shift effect as an insert on the bus to give a nice Doppler effect on the car stereo. Here's a nice real-world example. A lonely desert highway with a big tunnel through the mountains. The level is wrapped in an outdoors reverb zone, and the tunnel has an AK spatial volume with a big chamber-type reverb and portal on the exit. hear how the receivers change their reverb bus send to create a more adaptive and realistic soundscape. Because each receiver is an AK component, you can adjust RTPCs per instance to affect perceived amplification gain and speaker dimension, whatever you want. This level of control is actually impossible with the single component method. In the surveillance demo, the idea is that you'd want to hear both the emitter and the microphone aux bus. But for my situation, I never want to hear the transmitted source in the world. For my system to work, create a receiver audio bus and tick the Use Game-Defined aux sends if using spatial audio, which we are, and then make a transmitter aux bus as a child of that receiver bus. The transmitter aux is what you will feed to the Set Game Objects aux send values API. Set listener relative routing on both, but set the 3D spatialization on the receiver to position plus orientation, and the transmitter to none. No attenuation on the transmitter, and a general emitter attenuation for the receiver bus. I have all the radio stations here as music playlists. Their output bus is set to -200. You can see in the profiler, when I turn up that output bus, the music becomes a physical voice and begins to play in 2D. Tick Use Game-Defined aux sends to get the station sent to the 3D transmitter bus. The send volume will virtualize the music if set below the project threshold. Give the stations an attenuation, otherwise the transmitter game objects will always be sending signal to the late reverb bus of its associated room. Two ways around this. You can set the game objects to a position outside of any reverb zone or spatial audio volume in your scene, or set the transmitter max distance to a super small number, like 1. Set the 0 point to unity on the y-axis, then make a new point, set it to -200 on the y-axis, and scooch it as close as you can to 0. For me, it's 0.001. Turning on the attenuation, you'll hear that pure wet signal disappear, but the car is still receiving the bus. Your default listener would have to land pretty spot on to that transmitter game object to get that send actuated. This method feels a bit convoluted, so I might be missing something simple. Maybe it's just the timing of the spatial audio volumes being created in the world and overriding my subsystem setup. If anybody knows how to do this properly, please leave me a comment. I'd really appreciate it. Two side effects of using set multiple positions was 1. Volume control. If 2 or more positions are in close proximity, volume is non-additive, or can be non-additive, unlike my 3D-Bus scenario. Also, if you want the music to be fully 2D or emulate first person inside the car, you can turn off attenuation and 3D spatialization on that transmitter via RTPC. To get the same effect with the 3D buses, you have to remove all the receiver listeners and assign a new one. Either your player's listener, the AK component of the vehicle you're attached to, or any other game object. Then you set an RTPC that simply swaps output bus volume and game-defined aux send volume. So it's not impossible, it's just different. Left channel, right channel, left. Coming back to the source bus idea, my system here can actually be used to split multi-channel audio onto a 3D bus. This is one stereo sound being played through 2 3D buses. Getting this to work, at least in my Wwise version, required me to abuse 2 stereo delay effects on the audio bus. Then set an RTPC on the AK components for stereo pan, which basically blocks the opposite input by bypassing one delay and unbypassing the other. It's the only way I could find to isolate audio channels at the bus level. Now, this would 1,000,000% be a use case for using a type of multi-position call called Set Multiple Channel Mask Emitter Positions, or the newer Set Multiple Speaker Emitter Positions. But I'm pretty jazzed I got this working with the 3D buses. I think 3D busing and set multiple positions have great use cases, and clever use of both in your project would make for a really robust and immersive soundscape. 3D buses have per component effect control, and they play nice with spatial audio. But if you're using them for more static ambiances or need instance volume control, I'd probably go with the set multiple positions node. But both are great to use. So thanks for watching the video. If anybody knows more about this situation, I'd love to hear it. If anybody has any advice or critiques, please leave them in the comments. Thank you so much.